Hello everyone, this is Dhruv from Edureka and I welcome you all to this interesting session where I am going to implement and explain you emotion detection using OpenCV and Python. So let me show you what we are going to implement today. So hi guys, this is me. Here you can see different reaction it is showing right now. Suppose if I give a particular reaction, let me see if it's correctly detecting it or not. So let me make a sad face. So you can see it's detecting the sad face. Now suppose if I try to make an angry face. So you can see it's also detecting this angry face rightly, correct? So this is how it is going to detect the emotions. So let's understand how to code this project, okay? First, let me show you all the emotions that this project can detect. So here you can see different emotions like neutral, surprise, sad, angry, happy, disgust, fear. All these emotions can be detected. This is how I've detected from the same project. So now without any further ado, let's see the prerequisites for this project. So first we are going to have an introduction to deep learning. Then we will understand what is image processing. And then we will move on to understand the different kinds of libraries which we are going to use in the project. Then we are also going to understand the steps which we are going to take to execute the project. And finally, we will then implement the project. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technology. And also, if you are interested in postgrad diploma certification in artificial intelligence and machine learning by NIT Warangal, check out the link given in the description box below. So first, let's start with introduction to deep learning. First of all, let's understand the tree to deep learning. So in the tree, first comes the artificial intelligence. Let's understand what is artificial intelligence. So AI is any computer program that does something smart, or it can also be like a stack of a complex statistical model as well. AI can refer to anything from a computer program playing chess to a voice recognition system like Alexa. Now let's understand machine learning. So machine learning is like a subset of AI. This theory is simple. Machines take data and learn for themselves. It is currently the most promising tool in the AI pool for businesses. Machine learning systems can quickly apply knowledge and training from large datasets to excel at facial recognition, speech recognition, or object recognition, translation, and many other tasks. Machine learning allows the system to learn to recognize patterns on its own and make predictions contrary to hand coding software program with specific instructions to complete a task. This is all machine learning counts as AI, but remember that not all AI counts as machine learning. Now, finally, let's understand deep learning. So, deep learning is like a subset of machine learning, and deep artificial neural networks are a set of algorithms reaching new levels of accuracy for many important problems, such as image recognition, sound recognition, recommender systems, etc. It uses some machine learning techniques to solve real world problems by tapping into neural networks that simulate human decision making. Deep learning can be costly and requires huge datasets to train itself. This is because there are a huge number of parameters that need to be understood by a learning algorithm, which can primarily yield a lot of false positive. For example, you can understand deep learning. Like suppose there is a deep learning algorithm which could be trained to learn how a dog looks like. It would take an enormous dataset of images for it to understand the minor details that distinguish a dog from a wolf or a fox. So here we are seeing like how it's distinguished between a cat and a dog. So deep learning differs in machine learning in the way that it's a black box. Machine learning can be understood step by step, but deep learning is like a black box. That's why it is shown here. You can see in between input and output, there's a hidden layer. So a lot of background work goes in deep learning. So it's like a really heavy kind of an AI. You can say it like that, as it requires a lot of training as well, and it requires large data sets and everything. So that's how it differs from machine learning as well. So this is all about deep learning. Now let's understand what is image processing. So image processing is like a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. It is a type of signal processing in which input is an image and output may be image or characteristics features you can say associated with the image. So nowadays image processing is like among rapidly growing technologies. It forms core research area within engineering and computer science disciplines too. Image processing basically includes the following three steps you can understand, like importing the image via image acquisition tools and then analyzing and manipulating the image, and finally the output in which result can be altered image or like the report that is based on image analysis. So this was all about image processing. Now let's understand each of the libraries which we are going to use in this project. So first one is OpenCV, which is elaborated as open source computer vision library. So OpenCV was like built to provide a common infrastructure for computer vision applications and to accelerate the use of machine perception in the commercial products. Being a VSD licensed product, OpenCV makes it easy for businesses to utilize and modify the code. The library has like more than 2,500 optimized algorithms, which includes a comprehensive set of both basic and state-of-the-art computer vision and machine learning algorithms. These algorithms can be used to detect and recognize faces. Also, like it is used for identifying objects, classify human actions in videos, track camera movements, also for tracking moving objects, and etc. etc. Next is NumPy. So NumPy is like the fundamental package for scientific computing in Python. NumPy is facilitate advanced mathematical and other types of operations on large numbers of data. Typically, such operations are executed more efficiently and with less code than is possible using Python's built-in sequences. And the third one is Pandas. So Pandas is like a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and like for time series. So the next one is Keras. Keras is like a deep learning API written in Python, running on top of the machine learning platform TensorFlow. It was generally developed with a focus on enabling fast experimentation. So that's why Keras is simple but not simplistic. Keras reduces developer cognitive load to focus on the parts of the problem that really matter. Also, it is flexible. So Keras adopts the principle of progressive disclosure of complexity. Simple workflows should be quick and like easy, while arbitrarily advanced workflows should be possible via a clear path that builds upon what you have already learned. Also, Keras is like really powerful. So Keras provides industry strength, performance, and scalability. It is used by organizations and companies including NASA and YouTube. Now the fifth and the last one, that is Matplotlib. So Matplotlib is like a plotting library for the Python programming language, and its numerical mathematics extension NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits, means graphic user interface toolkits like tkinter and WXPython, Qt, or we can also say GTK. So this was all about the libraries which we are going to use in this project. Now let's see the steps which we are going to take for execution of the project. So first of all, download the dataset and code from description box, or you can create your own dataset as well. So if you open the link from the description box, you will get a GitHub link, and where you can like find the main Python notebook as well as the .h5 file, and also the video tester, the driver code you can see of OpenCV, which is also present here. Other than that, the second link is of dataset. Here you can find the training dataset. I hope you understood this. And then let's come back. The second step is to insert the dataset in Python notebook. And third is of course like the insert the required packages and libraries and like run the code in Python integrated environment, whatever integrated environment you have, be it Jupyter Notebook or it can be Google Colab as well, or any other Python integrated development environment. Also, you can like insert an image and check if it's correctly detecting the motion. After you have like done with the training of model, insert an image. You can like simply download any kind of an motion image from Google and insert it in your integrated development environment and check the detection if it's rightly detecting or not. Then you can like run videotester.py code, which is nothing but a OpenCV code to detect the emotion through like the live detection of emotion of your face. So run that code in Visual Studio Code, and so that's the final execution of the project. Now let's implement the project. So I have made this project in Google Colab. Go to Google Colab. So like you got this Dropbox link of dataset of training dataset. So you can copy the link and insert it here, and you can just give this code !wget to get the dataset. And then for unzipping the dataset, you can give this unzip train or ziptl. So it will unzip the dataset. So let's run this code. So then there are libraries. So you can see like all these images are unzipped, and we are into the dataset. So these are the basic libraries which we are going to use: NumPy, Pandas, and Matplotlib. Other than that, the deep learning library, that is Keras.application.mobilenet. MobileNet is like a pre-trained model. So you can simply understand what a pre-trained model. Like suppose I have some knowledge of, you can say, there's this topic of random forest. Okay. Now suppose if you don't know random forest and I know it. So if I explain you directly, I can specifically explain you because I am a pre-trained model. I am trained into it, so I can easily explain you. And suppose you want to understand it by yourself, so you have to do your own research. You have to like refer different sources and like different recordings, different courses you have to take, and that's where it takes a lot of time for you to understand random forest. But if you directly understand from me, I will very easily explain you. So that's why we use pre-trained model. There are like different kinds of pre-trained model. So I have used from Keras the MobileNet pre-trained model. Then we are pre-processing the input, whatever our data set is. Then we are going to use the functional API. That's why we are using importing model. And then we are going to like flatten and dense. So flatten and dense, you can take it like, suppose I'm taking different layers. Like if I give the value as dense equals to 7, so there will be 7 layers. This is how flatten and dense is used in Keras. And then we are going to use the Keras pre-processing image. It pre-processes the image, and image data generator is a Keras inbuilt function for like generating the images from our data set. We will understand that in a broader manner further steps. So next step is to like build our model to train the data. So we are going to use that same MobileNet pre-trained model, and in that we will give the input, which is the standard, you can say standard dimensions or standard values, which we are going to take, which is the industrial standard values 224, 224, and 3. And after that, include top false. These are the weights. So we have given false for all of them. So weights are given, and then to prevent like retraining of the model, we are using this loop. So we are using here like for layer this loop we are using, and for every layer trainability is to be false. So for that purpose we are equalizing it to false. Then we are going to activate the softmax layer. So dense we have given 7 units, so there will be like 7 layers. So after that we are creating our model. So this is the final model, and these are all the like categorical cross entropy. You can give it, it's your choice if you want to compile it through categorical cross entropy. If you don't even give this step, then also it will work properly. That's not a problem. After that, we are going to prepare our data using data generator, and these are the different ranges that are being provided in image data generator. Like if you zoom an image a lot, like suppose if you are zooming on your image, if you zoom in a lot, and it will just zoom into your nose, so it won't be able to identify your whole face. It will only be able to identify your nose. So this a certain zoom range need to be given. So here I have given 0.2, which is a standard zoom range. The zoom range lines between 0 and 1. Similarly, shear range lines between 0 and 1. And then we are going to rescale as well. So we have given by 255. So let's run as well. I think I haven't run these codes, so I will just run this. And after this, I have to run this one, model one. I did get run. Yeah. So this is the final model. We have run this and this. And after that, image data generator. So in that, see here, because we have run this, so we got our training data set here. And after the image data generator, all these values are given. And then the target size and batch size is given. So batch size, you can say like how many time it's going to run the cycle. Okay. So it's going to run for like 32 times. So that is the batch size we have given. So we will give it here. And all the emotions. So here we can see like 350 images belonging to 7 classes, as I have given the 7, what was that, dense layer, like so. Okay, so 7 emotions are here: angry, disgust, fear, happy, neutral, all of them are here. Then we are going to validate the model, so that's why we are using image data generator here. And then okay, so the same, if you here you have to give like the, because after this running this final model, you get this train. So here you can like click here and copy the path, and you can paste it here. So you will get the path of train, and here you can like generate the training data and all of the emotions we have found here. Similarly, you can for validation as well, for that's for training, and this is for validation. So we have given like validation data for that, and here also we are going to give the same path, copy the path from here and paste it here and run it, batch size 32. Then I haven't run this one, so I will just run this as well. On 350 images belonging to 7 classes. Then we are going to visualize the data that is fed to training data generator. So let's visualize the data. In that we have made this function for plotting the images. So it will plot all the images here. So let's run this. Takes it, and so it's plotting all the images for all the emotions. So now let's understand like early stopping and model checkpoint. So in this, there are like early stopping I have made differently. So yes, I have given like validation accuracy for it, and delta values and patience, everything I have given. And similarly, I've given it in model checkpoint, where it's going to like generate an h5 file for it. So you can give the file path as well for that. Like my file path will be best model or h5 file will be generated in my system. So after that, I will just run this, and you can see here the best model.h5 file will be generated. Just a sec. I've run this. Yeah, epochs also I have given. Of course, after training the model only the h5 file will get generated. So I have given like epoch 30, and that's how the number of time it's gonna run. Like you can see here, epoch 1 out of 30 is running right now, and steps per epoch will be 10. So 1 out of 30 it is running, and under that 10 steps will be there per epoch. So it will take some time. Let's wait for some time, and after it gets completed, you will find an .h5 file here. Okay, in this files section. So execution is completed. So you can see the H5 file is generated here. Now you can load the best fit model. Now we will just, for history purpose, I have given just assigned to H for all the, like I have separated into accuracy, validation loss, and validation accuracy. So that is all is generated. And then there is for accuracy and validation accuracy, I have visualized it. I have plotted it. So let's see the visualization for it. So lesser the difference between the validation accuracy and the accuracy, more stable will be the model. And similarly, lesser the difference between loss and validation loss, it's better for the model. Now I will insert an image, like just for checking purpose, I'm showing it to you. Like suppose I open this file I have downloaded from Google. I just very simply updated it here, and I just copy the path and I will paste it here, and I will just run it. So you can see the images of happy. So it's rightly detecting the emotion. Now let's move on to the driver code, we can say, of our OpenCV code. So this code you can also download from the GitHub link which I provided. Videotester.py code is there. So that we can import the CV2, which is nothing but OpenCV library, and then Keras, preprocessing, everything is just basic models and everything. Then we are going to insert the H5 model file which we have got from the model that got automatically saved in the system. So you can insert that file here. My name was bestmodel.h5. You can give whatever your name you want to, if you want to change. So here we are going to use the cascade classifier. I have assigned it as a face hair cascade, which is used for object detection. Like this hair cascade frontal face keyword is used for like object detection purpose. Then we are going to use cap. So this is CV2 capture video capture, which is going to capture our image from the webcam. And then like if the image is not empty, then we will continue. And the color is given, like suppose it's grayscale image, that will be converted into RGB. That's how it detects. Okay, so it requires RGB, so converts all the gray image into RGB. If it's already colored, then it's okay. If it's already in the RGB format, then it will detect the face. It will also create a like a rectangle around your face, any kind of geometry around your face. So this is the coordinates. This needs to be given like appropriately. So these are just nothing but the coordinates which are properly given. So whatever your face will be, so how it detects your face, like there will be a background image also, like there will be a wall behind you or anything like that. Sky will be there. So this coordinate will like crop your image of interest, like it has trained now. So out of that training, it have understood what it needs to detect. So it will detect your face, and remaining thing it will not consider. That will come under the cropping region, under that square or whatever the geometry we have given. So yeah, after that prediction, model will be predicted. So as the model is trained with all the 7 emotions, so it will crop your face on the basis of the training which it has got. On the basis of that, it will assign the emotion whichever it detects from the webcam. So this is what it is, and after that will cv2.destroy all windows. So it is for closing the project. So let's run it. So now we have got this. So now it's the live image from a webcam. Now suppose if it want to check for fear, let's check for fear first. So it's detecting fear, right? Then after that, if I want to check for happy, let's see. So it's detecting happy, but like because I have trained model not with a lot of images, that's why it's showing, it's actually like changing the emotion a little. But like if you train it with a lot of images, like say thousand images per emotion, then the accuracy can be like really good. So it's still like you can see the emotion it is showing. If it gets cleared emotion, then it of course show the right one. Like suppose if I try for angry, now you can see angry, it is showing absolutely right. So that's how it model works. I hope you have understood this concept. So let me stop this. I can stop this by clicking on delete. With this, we come to the end of today's session of emotion detection using OpenCV and Python. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!